In this video, we're going to explore how to use the Describing and Exploring Quantitative Variables Shiny app. The first thing you want to make note of is if you're using a single group of data or several groups of data, as noted up here. You can toggle between those by clicking on the tabs. Just like with the Categorical Variable Shiny app, you'll notice that you have the option to enter your own data or use something from the textbook. If you want to use a data set from the textbook, you'll just click this drop down here until you find the one that you need to select. So let's say you wanted to use hours watching TV. If you click on it, it'll auto-populate the descriptive statistics and then your box plot and histogram. If you wanted to enter your own data, just make sure that you choose between either individual observation or frequency table. Again, very similar to the other Shiny app that we had looked at in the previous video. And then you could choose accordingly. So off to the right here, I've already set up data, and what we have is a sample of patients and then their age when they were admitted. So two separate samples, slightly different sample size. Now, the one thing you want to make sure of here is when you are using these apps, be sure that the data you're looking at is actually what you're interested in. So for example, patient ID, that's just an ID number used to represent the patient in lieu of their name. So this way we have patient privacy in this case. So if we're curious about the age, then we are actually entering the age data. Now, something to be mindful of in this case is that if you're dealing with two samples, so we have two samples here, we would actually want to be using the several groups section of the app. If you had only one set of data, then you could go ahead and copy and paste your data in right here as we have it. I want to also point out for you, so I'm going to switch this back to just a textbook example, is that you do have a lot of different things that you can modify with this. If you wanted a dot plot, you could have it add that, though make note that the dot plot in this case is actually off the chart, so to speak. So maybe we would make those bins a little bit bigger or smaller, whatever you feel is appropriate, and probably shrink down that dot size. So again, it's not perfect, but you may have to play around with the settings a little bit. You could also, I'm going to remove this just for the sake of space here. You could also select stem and leaf, and that would give you a stem and leaf plot. For this set of data, there are a whole lot of zeros, ones, twos, all the way through fives, right? So you see all of this plus 20, that just means that it's basically run out of space, and there's a whole bunch more after that. Now, to hone in on some of the other settings here, you can change the bin width on your histogram just by using the slider here. So depending on the data set, it might make sense to have a bigger or smaller bin width. You could choose to include percentages. So that would be, instead of the frequency, you would use the percentages if you wanted. And then select where bin start, you could actually choose your first lower bound. So in this case, since the data starts with a minimum of 0, it wouldn't make sense for us to go necessarily smaller than that. You definitely don't want to go bigger than that because then you would be losing a bunch of your data. So if I set this to 1, see what happens. We lose everything that happened before that 1. Again, you have some other options, just like with the categorical app. You can change the plot title right over here, and it asks you which one you wanted to change. So you could give that a descriptive title. You could play around with the colors. Maybe you want your histogram to be purple. That would be an option. And then there's a linear transformation down at the bottom. Though this is not something that we would need to worry about in the beginning of the course, you may want to play around with that later in the course if you're looking at comparing z-scores or something of that nature, but there's other apps that can do things like that. So let's go ahead and work on an example. I'm going to click over to the several groups so we can compare the ages in these two data sets. So first thing I'm going to do is select my own. I do have two groups. If you had more than two samples, you could increase that number, right? If I took a third sample, a fourth sample, so on and so forth. And then the variable name, in this case, we're measuring age in years. So I'm just being descriptive on what that is. And you'll see it asks for the group name and then the group label. Well, the group name, this is based on patients. So let me start with the labels and let's see where that gets us. So we have sample A and sample B, just so we can discern between the two. And you'll notice that it now has changed what shows up in the descriptive statistics there. Now what I want to do is go ahead and copy and paste the sample data into each one of these boxes for their respective groups. So when I come in here, I'm going to start with sample A, highlight my data, copy and paste, and then repeat that process for the second group as well. And you'll notice it's already populated things like our sample size, our mean, standard deviation, etc. for sample A. And then when I put in the second sample, it gave us all that information. It should make sense that we have different sample sizes because you can see in the spreadsheet here that one of them has one additional piece of data. It's okay if you wanted to do this with different sample sizes. Just make sure that you're using this only to compare data that is of similar style. So in this case, we're comparing the age from two different samples. Now, a couple things you can also modify here. You can change your plot title, so whatever you wanted. You'll notice that that's representing this piece up here. We refer to them as side-by-side box plots, histograms, etc., because you're comparing two samples on the same axes. So that means that they're on the same scale. So anytime you're trying to do a comparison between two separate samples, this would be how you would like to use it, right? You want those on the same scale. So it shows you where the minimum, the maximum, it defaults to box plots here. You could change that to histograms instead. Not super exciting looking, but then you could also use a dot plot again. So in this case, because of the dot size, it's a little hard to see. But I would probably argue just for this set of data that the box plot was the easiest for us to read and compare. But truly, this is where you're going to be, this is the app you'll be using for those types of comparisons. Again, you can increase the group size, so you could have 3, 4, 5, so on and so forth if you wanted. This does really help when you're trying to learn about the shape, center, and spread of data. Not only is the descriptive statistics useful, giving you things like standard deviation and then the respective means, but it also shows you how the data sets compare visually to one another. So you can see that there's a very big difference in where the center, if we use median as a center, in these two cases are. Similarly, the means are also off by, it looks like, about 11 years roughly. So that is also a big difference. But the min and max aren't actually quite as far apart. Anyway, that concludes this video. Thanks for watching.